Do, 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 do.
What's it pay on GG1 at mobile?
Yes.
I don't know what that is.
At means attempt. Just what everyone says in the comment section of GD whenever there's a level. Somebody says GG1 at mobile and at means attempt. So they're saying GG1 attempt mobile easy. It's like there's like the hardest level in the game, hard rose. Everyone's like GG1 attempt mobile. GG1 at mobile. Easy. GG easy 1 at mobile. What's your fan UFO, Geist?
It's bad. Also don't know what
I
it is.
agree. You're better off not knowing. To have been UFO Geist pilled. Yeah, fucking Bruce. Well, let's be our GG1 at mobile moment.
Yes.
I literally clicked.
Yo, it's Parker.
This game is such a joke, man.
What's up, Parker?
Yes.
Does Dylan
Yeah,
have new
Lord Van
emotes?
Cam.
I love that.
I tell Danny Can to get on Discord.
Yeah, get on Discord, Vanican.
Or else he's gonna say I Vanna can't walk.
Dude, I loved watching that League streamer try and pronounce Vanican. The one that was doing the giveaway that we all followed.
How many
Which one was
followers do you
that?
have?
I don't know. He probably almost has 400 though. He was already at like 340 or so.
Yo, Vanny Can is on GD.
Is he talking right now? I can't hear him.
He is
Huh?
not.
No.
Vanny Can's not even
Yeah, he's not in the
in
call.
Discord.
Okay. Okay. Oh yeah. I put on that lo-fi.
Oh, finally beat UFO Geist. Okay. Done with that. Alright, the final map pack, boys. I'm gonna get this one somewhere.
Hey, I hit 30 followers. I got a follower 8 days ago, just randomly. Your M underscore. Thanks for the follow.
God, that's stupid.
Oh, you know what I could do? Play Age of Empires.
Or you can play Dry Out.
Play
Yeah.
what? What's that?
Dry Out.
Yeah.
It's a GD level.
Yeah, you didn't know that, dude. We're gonna put you on the cringe list.
Yeah. I mean,
You
I am
already
pretty
are on
cringy,
this.
so makes
Yeah,
sense.
just turned.
No, you're like the opposite of cringe. You're better Head United.
Yeah.
This video was really good.
Dude, I don't want to change that name just because it's like such a meme.
Yeah, true. It's iconic.
Yeah,
It's
yeah.
iconic, dude.
It's like part of the. It's like part of like the American like.
The American dream.
Yeah, honestly.
Not a true American if you haven't heard of Barrelhead United.
I have a dream that one day Barrelhead United will like rule the world.
We'll become a terrorist
The
organization.
Barrelhead United States.
Ah,
World War III's Barrelhead United versus every other country in the world combined.
maybe when I'm barrelhead. Bum, 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 bum. Bum, bum, bum. Bum, bum, bum. Bum, bum, bum.
God. Alright. I don't know. I'm not feeling the gaming right now.
What do you feel?
You could just
love.
I don't know.
yode on them. You could do a coding stream.
It could be
You
what?
sh- Yeah, you should just do
A
a
coding
stream.
stream.
Oh.
No, you should do a stream where you're just reviewing YouTube videos, and they're all
No.
jokes.
I have been meaning to learn C++.
True.
Could do that on stream.
What about F?
Huh?
What about F?
I don't know what you just said.
F.
I don't
F?
I don't think they're words, so
Yeah.
it's fine.
What the fuck is F?
It's a programming language.
Is it? I don't think
Yeah.
I've ever heard of that.
Yeah.
What about P?
Yeah, P, it's a singularity. No, you should learn white space. That's a funny language.
Oh, interesting.
We
Alright,
learn
I
funny
see what
things
F
here.
is.
We do
It's
very serious stuff.
And they also have F sharp.
wow. That's pretty advanced.
No, you should, white space is pretty
What
chill.
about F dull? You know what I'm saying, Jack?
Alright. Look up C. Learn C++. Here we go. It's supposed to take 25 hours.
To learn the language?
Damn, dude. Yeah.
Doesn't seem that bad.
Right? Alright.
Alrighty then, it's me, British Jose, back at it again, another YouTube video. Yay, nay, nay.
Sick output potential.
What are you talking about?
Just talking about
That's about right.
Mathura.
Geometry Dash?
Alright.
Poetry.
Guess I'm gonna finally do this.
I need to get back on Unity. That reminds me. Well, one of these days, right, boys?
Yup. Jimbo followed 24 days ago.
But
Oh,
there's
I
that guy,
miss
there's that
Jimbo.
streamer who beat Deadlock in his 5th day of playing with 60 hertz, so I got some catching up to do.
I thought you were talking about grinding Unity so you could make your card game.
Yeah, I need to do that too.
In what order though, you think?
Yeah, I'm not really 100% sure on that yet.
Which one do you think is more important? Probably beating Deadlocked, right?
Probably.
Yeah, true. Well, first I gotta get glow effects so I can be good at this game. I'm literally just 3 maps away from getting glow effects.
Death.
God!
Wow. Are you okay?
Dude, there's a guy who was literally playing Rob Top Travel 2, and he died on Star Dynamics.
Clutter step.
Yeah, sure.
I lied. I'd like something made. Let's see what materials I have. Oh wait, this. Oh, I'm supposed to go to the alchemy table. I'm so grieved. Oh, what's a wind catcher?
Are there like high-profile defense contractors in Genshin Impact?
Only me, I think. 50.
So what does the impact mean?
What are we talking about?
What does the impact mean in Genshin Impact?
Oh, the impact of my hand going straight through.
So I know that guy, the company Metagame, also made a game called Honkai Impact.
Yeah, I think they just have a fetish with impact,
Yeah.
like the League of Legends.
Like the
player.
font.
The Team Liquid Impact.
I was thinking the font, but that works too.
Well, they have a fetish with that guy too.
What, the font is a person?
Were you saying fonts can't be people?
I mean, they can. Like Papyrus
You're a racist?
and Sans.
Yeah. Sans Undertale.
Even though like there's so many fonts that all
Even though,
fall
like,
into
there's
the
so
Sans
many
category,
fonts that all
Sans Serif, and Comic Sans is just one of many.
Yeah, but that's the only good one. All of the ones are racist.
I know. You know, there's just garbage like Arial and Calibri and stuff. Honestly, Calibri is just so clean. Like it's like the best font
What
ever.
about Calibri?
All right. I'm gonna do this. 40 years ago, a PhD student by the name of Bjarne Strustrup tinkered around with the C programming language, which was and still is a language well respected for its flexibility and low-level functionality. Little did he know, he created a new language that can now be found in operating systems, web browsers, microcontrollers, whatever that is, video games, and elsewhere. So this course will start with the fundamental programming concepts before digging deeper in the more advanced C++ topics. You'll build everything from a Harry Potter sorting hat to a program that can censor text. Wow. It's thrilling. Alright. 25 hours, huh? Yikes. Should've looked at the syllabus. Oh well. I think I will actually look at the syllabus. See what sections I gotta do. Alright. Okay, so we go up to references and pointers. Interesting. It's probably about where I need to go for school. I'm learning C++ because I'm transferred to a community college that I was not going to previously. And originally I was doing all of my classes in Java, but this particular college does it in C++, so I have to learn C++ up to the point that I should know to at least have a grasp of understanding. Alright. C++ is a programming language created by Bjarne Strustrup. Let's see. Oh, wow. He's very old. Alright. Interview. Okay. I mean, he's still alive, so makes you realize that it's really not that old, is it? I guess. Alright. Imagine having that as an office. Kind of cool, actually. I like how they add a grayscale to this, but I mean, it's pretty clearly modern. Why should we do this, huh? This is probably it. This is what's gonna drive me through this. C++ is one of the most useful languages there is. There should be a sufficient reason. Someone wanting to be a professional should know a few languages, not just one. And C++ is a good one to know for work that requires performance and reliability. Another way of looking at this is that C++ is very widely used in finance, games, telecom, electronics, and manufacturing. See JetBrains blog post in my C++ applications page and try to guess why a language without marketing is so widely used. It has a website. Wow, this is not a very pretty website. Systems. Oh, so this is just like his bragging board. That's funny. Alright. Gotcha. Alright. Alright, buddy. We get it. You're cool. In my opinion, the best reason for learning C++ is that it gives you insights into a variety of programming and design techniques that are applicable in a wide variety of languages. Alright. Alright. Let's actually start the course now. Of course, we gotta read this. C++ programming language created by Bjarne Stroustrup. It is. I'm never gonna get over that name. He looks like a Bjorn, doesn't he? It is team at Bell Laboratories in 1979. Bell Laboratories made everything, dude. That's crazy. 40 years later, it is one of the most widely used languages in the world. We can find C++ applications everywhere from the bottom of the oceans to the surface of Mars. As the name implies, C++ was derived from the C language. Bjarne's goal was to add object-oriented programming into C, a language well respected for its portability and low-level functionality. So why learn C++? Among many other things, it's fast and flexible, it's well supported, it forces you to think in new and creative ways. In this lesson, you'll start learning some basic concepts, and you'll write your very first C++ program. Don't worry if some words don't make much sense right now. We'll learn about them in a bit. Alright, good art. Take a look at the hello.cpp file in the code editor that is placed in the middle of the screen. It's a C++ program. Yes. In our code editor, the file name is displayed at the top. Yeah, alright. C++ programs are stored in files which usually have the file extension CPP, which stands for C++. The code inside our C++ file is a classic first step all new programmers take. They greet the world through the terminal. The terminal is the black panel on the right. Woo. It should be blank right now. The code in the text editor will print text out onto the terminal. More specifically, it will print the phrase, "Hello world." Before we explain what that mumbo jumbo is, let's run the program to see what happens. Press run to see this program in action. Hello world. Nice. So the main function is an integer function. That's kind of weird. Yeah, that's weird. Output. High five. Whatever. Okay, so it runs line by line. Pretty typical, top to bottom. So yeah, you have your libraries at the top, and then you have your functions and all that, and then you have the end of the function. It's the curly braces that we're going to focus on for now. So std : cout is the character output stream. It is pronounced cout. What's this called? The like double rocket operator. Oop. Okay, yeah, that's what it's called. It's a shift operator. I forgot about that. Don't use those very often. So left shift and right shift operators in C and C++. Left shift takes two numbers. Left shift shifts the bits of the first operand. Oh, where is it here? Oh, here it is. Okay. Okay. Interesting. second operand decides the number of places to shift. Okay. So equals, okay. So A shift 1. A shift 1? What? Oh, okay. So everything's always in 8 bits. I don't know what A is. What is? Oh, God. Okay. That makes a lot more sense. Oh yeah, and shifting multiplies by 2 or divides by 2. That's another property of shifting. Okay, so these are both right shifts or left shifts? These are left shifts because it's getting bigger. So a left shift will double the number because in binary that's just how it works, coincidentally. Although I guess it's not really a coincidence. But when you have a number system based on 2, that's what it's going to do. So it will multiply by 2 if you shift all of these. So what's happening is this bit is getting shifted to this position and so on and so forth. So 5, which is A right here, A equals 5, and this is 5 in binary. So this is how the program actually stores 5 as a sequence of 8 bits. This is the 4 and the 1, and you add that together, that's 5. So you're shifting it by 1 place. That's what this 1 is for. So now everything's going to be moved over 1, which means that it's actually going to double the number because that's how it works. That's just what it works out to be like. So this is the actual bit, or the stream of bits that comes out of shifting this A variable, which is assigned 5. I don't... Anyway. So yeah. Since it's all moving over 1, it happens to double. It's good to know. Left shift doubles, right shift halves. And as you can see, this comes out to 10 right here, because this is 8 and this is 2. Add that together, it's 10. Same thing here. This is 9. Shift by 1, 18. If we wanted to shift by 2, it would actually come out as... I think it might come out as 36. I don't quite remember if it doubles this number or if it doubles the original number being 9. Well, okay, sorry. I don't remember if it doubles the number after it already doubled. So 18 has already been doubled. I don't know if it doubles this number again, the 36, or if it doubles 9 twice. Or yeah, so, or if it like multiplies 9. You know what? No. Okay, I'm almost certain that it doubles this number. In fact, we can just look. This would be so this is the 1, 2, 4, 8, 16, 32, and so 32 plus 1, 2, 4, 32 plus 4, 36, so it doubles this. Okay, great. So basically all that means is that if you shift it by more than 1, it just keeps doubling the number every time you shift it by 1 place. So, and that's a left shift. And it looks like that's indicated with less than signs. So, because it's pointing to the left, I'm gonna assume that's why. Good to know, good to know. All right. So we have the std cout, which is the character output stream. We have the left shift operator, and we have a string hello world with a new line at the end. So you need double quotes around the text. The \n is a special character that indicates a new line, and then we have a semicolon at the end. It's punctuation that tells the computer that you are not, or that you are at the end of a statement. It's similar to a period in a sentence. Let's write the whole std cout. All right. What is this, like standard something or other? I don't remember. I've never used C++, so I'm not sure. So this is character output stream, and then we use the left shift operator and we put a string here. We're gonna do Codecademy, I guess, with a new line at the end. And don't forget that semicolon. All right. I think it's interesting that we're using a left shift operator here. I am curious to see why you do that. Like, what is it about this string of bits when you shift it? So, oh. Wait, so you're shifting this by this. Oh, that's interesting. Okay. So the program, this is really strange. I mean, it's cool. It's clever. But I think what's happening here is that, like, it's sort of being encoded and you know what it's going to come out as. If you shift it by a certain by a certain string of characters, it can probably decode what it shifted it to. And then that's what this program... Well, I also need to know what the heck this part is. I don't know what std : is. Anyway, this is interesting to me. We learned how to output a line of text with the following code. stdc out, left shift, and then anything. It will output this, of course. We can also output multiple lines by adding more stdc out statements. I'll just say cout from now on, why not? So yeah, we just have 2 hello and goodbye. So instead of displaying those 2 lines in the output, edit the code so that we output the following pattern in the terminal. Exactly how it is. Remember, you can use a hint if you need help. Okay, so we're gonna have to put white space in front of the 1 in all these. It's unfortunate. So I don't want to count. But actually, I don't need to count. I can just copy it. There. All right. I'm just gonna copy each one of these. And then I'm gonna get rid of this. All right. Copy this. Stick it in there. And the last line, stick it in here. Now we have 4 couts. And I believe this is what they wanted. Yep, here we go. Great. Move on. Wow. That was quite the achievement. We've written a few C++ programs. Wow, yeah. I'm basically a programmer at this point. In this lesson, you have learned C++ is a general-purpose coding language. C++ runs line by line from top to bottom. stdc out is how you output to the terminal. Good luck. That's funny. Got it. Before we move on, let's write a letter to your future self. In letter.cpp, let's add the following. Goals for yourself, name and date. Dear self. All right, let's do this. Cout. Or not count. There. Please finish this course for the love of God. New line. Love, John. Oh shoot. Wait, I also want to put a new line here. And this is off by 1. Oh! I'm so foolish. What a nubile mistake. Good thing I'm brand new to coding, right? Yeah, you've got to put semicolons in this program. In this particular language. In a lot of languages, but this one too. Which kind of sucks. Because it should be smart enough, but you know. It's pretty rudimentary. It really lets you get really picky with how the code runs. So in the end, it's a good thing, but it depends on what you're trying to do, right? Anyway, dear self, Please finish this course for the love of God. Love, John. Wow. Let's see. We're gonna finish this Hello World section, I don't know, like in a matter of no time. C++ programs have a very specific structure in terms of how the code is written. There's some key elements that you use in all your C++ programs. Here we have a program called hello.cpp. It's a classic first program. This program outputs the message hello world to the monitor, include IOStream. And then we have a main function here that's of an integer. Okay, I'm sure they will go over that. And then the body of the function contains the cout with a hello world new line, and it returns 0 at the end. So you do have to actually return an integer or the program isn't going to end. Interesting. This program writes the phrase hello world to your terminal. C++ is a case-sensitive language. Case sensitivity means that your keywords and variable declarations must match the case. For example, the C++ keyword for outputting is cout. So if you were to type cout or all caps cout, the compiler would not know that your intention was to use all lowercase cout. All right, don't leave caps on. Don't be intimidated by all the new information. You'll learn about all these things and a whole lot more. Let's go over this hello CPP program line by line. This program outputs the message hello world to the monitor. So this is a single line comment that documents this code. The compiler will ignore everything after the double slash. The end of the line. Nice. So you're telling me that this programming language, the compiler or whatever, is smart enough to know when the line ends, but it still makes you put a freaking semicolon at the end of the line when it's not a comment? That's kind of lame, not gonna lie. A little lame. I mean, I understand why, but like, it's sad. I wish that wasn't how things were. Really, I truly do. Alright, so you'll find this, or sometimes you'll find this comment to include the author's name or document what the code does. So yeah, tells us what it does. That's pretty important. Now we have something else here. This is known as a preprocessor directive. Fancy. It instructs the compiler to locate the file that contains code, or a library known as IOStream. This library contains code that allows for input and output, such as displaying data in the terminal window or reading input from your keyboard. Interesting. Okay, so even if you're not going to read anything in your program, in order to even output anything onto the terminal, you need to include IOStream. So this is an include. It's a package. Interesting. All right. We'll go over that later, I'm sure. So every C++ program must have a function called main. A function is basically a sequence of instructions for the computer to execute. This main function houses all of our instructions for our program. This is where we will be writing our code. Great. All right, and then we have the cout. This code uses a method known as cout. To send the text hello world to the terminal for output. Then we have a return statement at the end here. So the return statement is used to end a function. If the program reaches this statement, returning a value of 0 is an indication to the operating system that the code executed successfully. This line of code is optional. Oh, it's optional? Well, shoot. Okay. Why would I ever put it? C++ programs permit judicious use of white space, tabs, spaces, new lines, to create code that is easier to read. The compiler completely ignores the white space, with a small exception concerning if statements that will be covered later. It is highly recommended that you make use of white space to indent and separate lines of code to aid in readability of your source code files. Yeah, if this was all on one line, and you had 10,000 lines of code, it would be hell. It's still gonna be hell, but it'd be a little less hell. So compile and execute. Interesting. All right, so code, save, compile, execute. This is our life cycle as a programmer, I see. C++ is a compiled language. That means that you get a C++ program to run, or that to get a C++ program to run, you must first translate it from a human readable form to something a machine can understand. That translation is done by a program called a compiler. When you program in C++, you mainly go through 4 phases during development. You code, which is writing the program. You save the program. Hopefully you do that while you're coding. You compile via the terminal, and then you execute via the terminal, and then you repeat. Up until now, we've been doing the magic for you. Steps 2, 3, and 4 were all done by simply pressing the run button. Let's try compiling and executing using the terminal. All right. So we're going to compile. A computer can only understand machine code. So a compiler can translate the C++ programs that we write into machine code. To compile a file, you need to type G++ followed by the file name in the terminal. The compiler will then translate the C++ program hello.cpp and create a machine code file called a.out. Okay. It's a little silly that it's called G++, but maybe there's a reason for that. Or I shouldn't say maybe, there's always a reason. But, you know, I think learning that reason will help us remember this kind of stuff. G++. Let's see what G++ does. Compiling with G++. So G++ command is a GNU C++ compiler invocation command, which is used for pre-processing, compilation, assembly, and linking of source code to generate an executable file. The different options of G++ command allow us to stop this process at the intermediate stage. So I guess it means generate. I think that's why it's a G. It's probably generate. Sorry, Weeb, I know. This is probably not what you're expecting to come back to. I'm learning C++. I need to learn how to do this because in the college I used to go to, we were using Java, but now we're going to be using C++. So, yeah, I should catch up on it. Luckily, it won't be that difficult. If you want to learn how to code, stick around. I've been narrating everything I'm doing, so, and I'm trying to boil it down to it like the most simple terms possible, so that like anyone could get a really good grasp on this. I don't know why. I'm just doing it. It's not like really anyone's actually going to benefit from this, but so yeah, we just learned about the life cycle of making a program in this with this programming language, and we use this command called G++ that is going to generate an executable file. So that's why it's G and not C, which is definitely yeah, it does. I think it does. It helps me remember. When I narrate things out loud, I think I remember things a little better. That's why a lot of the time, if I really want to remember something, I just read it out loud instead of in my head. And it helps. It doesn't make a huge difference though, and quite frankly, I don't really need to remember most of this because I know a lot of it. But it's good for the basics for sure. This music is getting louder. Why is it getting louder? It's good music. Alright. Okay. I'm gonna continue now. So I'm gonna reread this. When we compile it, so a computer can only understand machine code. A compiler can translate the C++ programs that we write in English into machine code. To compile a file, you need to type G++ followed by the file name in the terminal. Okay, so the file name is the argument. The compiler will then translate the C++ program hello.cpp and create a machine code file called a.out. Interesting. So then to execute it, all you need to do is type and the machine code file name in the terminal. Okay. The executable file will then be loaded to computer memory, and the computer's CPU executes the program one instruction at a time. What's up, Ahaz? Let me assist. Oh, would you like to co-teach here? You can join a call. Want to join a call with me? Okay. Here, you can see which call I'm in. Special guest speaker Ahaz, who is a professional at C++.
Hello. Hi.
Hello. Welcome. So,
Okay.
you know what? I'll share my screen with you so you can see what I'm doing.
It's in real time.
Yeah, it's actually not that far behind on stream. Yo, all right. So we're learning about compilers. We're learning about how to compile and execute our code. Ahaz, what can you tell us?
Cringe. I hate compilers. I hate Eclipse. Eclipse is an awful IDE. That's just a piece of
I
shit.
don't like Eclipse
and-
either.
But Eclipse is the only thing I know how to work with. Is that's what Saddleback's Intro to the CS teacher taught me. So,
I only have Java Eclipse downloaded.
I think you can install C++. For the way it was done for me, I had to install MinGW compiler.
I don't know what that is.
was- You'll have to. It's like I wish I could find the tutorial that my teacher had. Because it was very simple. It's very easy. All my shit is on my laptop.
Oh, hey, it still has some stuff in here? What in the world? Since when? Oh, I have the Bayesian statistics program I made. Where is that? Oh, here it is. Oh, so I watched a math video or something. What's the stand-up maths? I watched a video from stand-up maths about Bayesian statistics, and then I made a little program to like test out what they were saying, and it was kind of fun. I kind of forget what happens here, but it's about like approximating coordinates or something like that.
Interesting.
Let's see.
Very
Let's see. I can
In
run
C++,
it.
it'd probably be a piece of shit to code in C++.
Probably. Everything's a piece of shit to code in C++.
But if you're good at C++, then it's very nice because everything just flows together.
So, would you like to enter your own point for me to guess? Oh, I remember how this works. So I can say yes or no. I'll say yes. Okay. Now it gives me directions. Please remember to keep all of your coordinates positive, less than or equal to 100, and non-zero. Decimals are okay though. Enter your x value. I'm gonna do 50.75. Enter your y value. I'll do 3.12. So what happens here is it's way more. Why wouldn't you use? Oh, don't worry, I haven't pressed enter. I can use 69.69. There you go. There you go, Weeb. There you go. Yeah, I know that was a crisis averted right there. I think when I hit enter here, what happens is it creates a bunch of random so like it generates a graph. It doesn't really, but I just pretend like it does, and then I use the math to figure it out. But all I do is I think I throw 100 random coordinates onto the graph, and then I measure the distance between the given coordinate and the random coordinates to try and approximate its location. It's a lot more simple than it sounds, I promise. Like, this is literally all of the math. Like, that's not a lot. So, anyway, let's see what happens. Oh, I can choose how many different coordinates I want to put in. Okay, so I'm gonna choose to put in 200. I approximate the point to be at 48.75621 blah 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 and 72. The point was really at this. So the more trials, the closer it's gonna be. Percent error for x value. Okay, yeah, and then I give percent errors. Okay, I want to do this again. Okay. You know what? I won't bother making one. Enter number of trials to run. Let's go with 2,000. Oh, that's so much closer. See, these percent errors are so much better. See, this is cool. Don't tell me this isn't cool, all right? This is fun.
It's just statistics, right?
Yeah, I mean, it's fun. Watch a stand-up math video and then you make a program. Man, I forgot about this thing. This is awesome. Let's see, what else is in here?
How old is this?
I don't know. Probably like a couple years old.
Really? Oh man.
I don't know how to like view when I saved it last. Oh well. Yeah, it's
Yep,
probably
looking-
about 2 years old.
Eclipse like main program.
But let's see, what's this? Excel Bayesian. Oh yeah, and then I made a cool thing. Okay, and then I made another program by like I copied a lot of this code and then I edited it in a separate program right here. And I basically exported all of the data to an Excel sheet and then processed it on Excel automatically so that when you like put in the number of trials, it'll show like how close it gets to the actual like number like per trial. So I have a picture of it somewhere. Let me see if I can find it. I have a picture of the graph that this particular program generates right here. Coordinates, yeah. So this is the coordinate class, and then this is a coordinate runner. Yeah. Okay, I'm remembering this. Oh, this is so fun. All right. I don't know where that graph is, but you can tell like there's like a certain point where it just doesn't matter anymore. Like how many trials you run, it's gonna be super accurate. So.
Yeah.
Oh, Bayesian experiment data. Oh, I found it. Oh, okay. So this is 100 errors. So after the first trial, it's, or after like at the beginning, it's got some pretty awful percent error. But then as you get more trials, it gets closer and closer to the actual number. So the lower the percent error, the closer it is to the actual number, right?
Yes.
So this is up to 100 trials. And this is up to 60,000 trials right here.
Oh my god.
So you can tell, like, after this point, it pretty much, like, it's pretty much fine. Let's see.
Yeah.
Let's do 300. Let's see. This is the 300 one. I have one for 300, 600, 10,000, 60,000, and 100. Yeah, I think this one's probably the best one.
What is that?
So, like, you can tell that it, like, doesn't matter all that much anymore. Like, it really depends how precise you need to get, but this is cool. It's super sporadic, and then it quickly goes down, and you can... Oh, it's just cool.
What's Ethan? Oh, Ethan.
Yeah.
Oh, yeah, what's up?
Here to join the party.
Oh, I need to
Oh,
charge
dude,
my laptop.
I forgot about all of this. This is so cool.
When I
Alright.
look at my 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 recursive algorithms,
Oh.
Fibonacci sequences.
Oh, I'm sure. Yeah, sure.
But they're all in C++, and they're all my laptop, so
Oh. So,
kind of
can you show them or not?
I can maybe. I think I have to port them over.
It's a vehicle
I
thing.
need to charge my thing. Charge my
I don't remember what any of this is. This was so long ago. Alright.
charger is in.
Ahaz, the stream has been making less progress ever since you joined. We were
Yeah,
we were
because you've been like,
speeding through Hello World like crazy.
because you've been, dude. I can speedrun you through the whole thing. Watch.
Fine. All right, we're gonna learn how to compile real quick. So, do you think you can show us that or?
Compiling?
No,
Is-
I meant your recursive thing.
Oh. Let me see if I can.
Weeb is angry that you're holding us up.
I don't care. If we wanted to rush, she would learn C++ herself and then just, do it for you. I think she can do it. I have faith.
I think anyone can do it. I think that if you just give it time, anyone can do it.
Well, I think you can do like ASCII art and stuff.
True.
Eclipse Workspace.
It'd be
number
cool if you
4.
learned how to program and then like made a program that converts good art into ASCII art. I'm not trying to say that, good art isn't ASCII art, but it kind of isn't. All right. So, do you think you can show that recursive thing? Sure.
Maybe I can upload it to the. Oh wait. Okay, yeah. Oh man, this is an old. Ooh. What happened to my Discord? I think I need to Control Shift.
Okay, real quick, I'm
And
gonna
tab.
compile and execute this code. All right.
Okay, I need to log in with my QR code.
So we're gonna compile this file real quick using the G++ keyword as instructed to over here. And then the argument is the name of the file, which is hello.cpp. So, and it looks like it did nothing, but it made a file called a.out, which is the executable file that the machine can actually read. So to run that, you just do /a.out. Hey, it worked!
Alright,
Hello world!
phone is-
There we go. That means the code ran. So that's all we did.
There it is.
Pog.
Nice. You're doing this in command prompt?
I mean, Codecademy, yeah. That's just what they do. I'm mooching Codecademy Pro off of somebody else, so I take advantage of it.
Okay, I'm logged in on computer. I can send it to myself.
Yeah, that's true. This is my friend's account. And he bought a year. So, And he
Okay.
got it for me because he was my old boss. So I actually learned how to code certain things that I needed for the job on Codecademy. Yeah, it is kind of expensive, but I got a sweet deal out of getting, Codecademy Pro for free. It's been super cool. While we're waiting for Ahaz, I could browse through the other things that I've done on this account. This isn't my personal account.
Let's see. Users.
God, what is this? Why does it look like this? Oh, I know why it looks like this. Oh, really? It just looks like this normally? That's kind of weird, dude. Not gonna lie. Oh, okay, so these are the ones that I've completed. I had to do a lot of stuff with Ruby and Ruby on Rails and then authentication with Ruby on Rails. So I learned all the Ruby stuff. And I also did JavaScript. Because I was like helping with like making a website.
It's not there. Why is it not there?
Oh,
Open project from file system. I need to directory. This thing is like super scuffed. Users, Ahaz, Eclipse Workspace, AS4.
What the fuck
Finish.
is non-technical life skills? Oh yeah, so I looked at this one briefly, and it's basic stuff that you should be taught in school, but you're not taught in school. At least you're not taught here, like making budgets and retirement. So I was looking through it, and it has some stuff. It wasn't exactly difficult. But yeah, I was like, maybe there's something, maybe I'll learn something. I kind of didn't, but hey. Yeah, exactly. I know. It's it's bad.
All right. It's up.
Oh, this is a thing now. I don't think this used to be a thing. 35% less. see. I think this is new, Weeb. I don't remember this being a thing. Yeah, I know. I know this is what you meant. I just didn't know it exists.
Oh, that's
Until
what
now.
function.cpp is.
My god, you can buy a hat with your preferred language's logo on it.
That's amazing. John, my thing is up.
Cheat sheet.
Fully.
Oh, is Ruby on this? No, it's not. JavaScript is. Let's go.
I build this.
Oh,
Will work. Thing is working.
get a hat. You know, I could see
Zero
myself in
error
one of these too.
Hogs. Oh, run as.
All right. What's the C++ cheat sheet? Oh, new line. We learned new line already. That must mean we're professionals. We're already one step into this. Actually, this is very short. What the heck? Oh, it's like the most basic stuff. We learned almost all of this already. All we didn't learn was multi-line comments. That's it. I'm not getting a hat. I'm not gonna do it.
I guess John just
Oh!
isn't interested in my
I'm
thing anymore.
stupid. No, I'm just waiting for you. I don't know.
It's been up
Where?
in Discord. I've been streaming it.
Oh, you're streaming it. Okay, well I didn't know you were streaming it.
Because you want me to like send it to you when you don't even have C++ installed? What?
I don't know. I didn't know what your plan was.
Whatever. Yeah, this was old stuff, but here it is in the console.
Yeah, this is from back in April.
Yeah.
This was actually during quarantine. It's weird to think about.
Quarantine just started.
God,
Yes.
it never stopped. Never going to stop.
Oh, what is this? Oh, this is high resolution clock.
So what is this?
This is the way this is my main where all the stuff starts basically.
Mm-hmm.
My three variables, a long number used for general calculations, int counter used for general calculations, and int input menu, just input by user from menu navigation. Print headers for this bit right here. This is what it displays and waits for the input.
Yeah.
Let's do 1. Enter an integer between 5 and 15. What's your favorite integer between 5 and
13.
15? 13. Okay, that's the factorial for 13. Nice.
Okay. Oh, I see. Okay. Oh, so it'll either display. You can choose. So this is a menu from 1 to 6 or 1 to 5, and 5 or 1 to 0, I guess. 1 through 4 and 0 is exit. So you have 4 options. You can display a factorial of a number. You can calculate the Fibonacci series of a number, or you can compare performance for factorial implementations or compare performance for Fibonacci series implementations. Is that just like runtime? What is that?
So, my throat is so hoarse. There are 2 algorithms I've made for this assignment. There's an iterative and there's a recursive algorithm. So, iteratives are like normal loops. While counter is greater than 0, number equals number times counter, counter minus minus return number. So, this will calculate the factorial for the number.
Yeah. Okay.
This one right here is a recursive series where you start out with, I think counter minus minus. Let me see what it is. Main. So, think for both of these, it does the recursive for 1 and 2. So what we just saw was the recursive algorithm at work. And then this number 3, under 3, it starts measuring the time between for how long each algorithm takes. The,
Okay, yeah. Okay. So
so-
okay. Yeah, it measures the runtime for these two. And it tells you essentially how long it took the computer to figure it out.
in microseconds.
Yeah. Which can be helpful. You know.
So for those kinds of things, for a number like 5, it's not really that big, but let's do 3 again, and then let's do 13. Pretty, still not that. What?
What?
Why did it take?
What?
It took shorter for both of these than it did for 5. But the recursive took less time than.
Yeah, you can see that the recursive took less time in one of them and more time in the other. I think also the problem is that that's such a simple calculation and it's such a low number that it's sort of sporadic because the compiler is doing different things depending on just the digits that you input.
So yeah.
If you
Basically,
put
the heart
like
and soul.
120 million, then you'd see a big difference.
Let's try it.
Even
Doesn't
that,
change. I think it gives up after a little bit.
it might.
I
You might
don't
be
remember
running
how-
out of like memory or something. I don't know. I kind of
know
doubt it.
This wouldn't run out of memory. I have 16 gigs. I'm chilling. But yeah, the heart and soul of recursive algorithms is that you just slap the function inside of itself. That until it reaches this state where it exits the loop,
Called a break condition.
yeah, you break condition, except you don't use breaks. And here's my fib series, which we haven't used yet. Let's do that. 2.
All a recursive function is a function that uses itself in its own body.
Yeah, exactly. Instead of looping based on comparisons, like iterative functions,
Yeah.
it will try to reach the base case. I think.
Yeah, the base case, that's what it's called. Not a break condition, sorry.
I think this is recursive series. This was a very interesting algorithm to make.
I don't really remember how the Fibonacci sequence works.
It's like 1, 0, 1, 1, 2, just adding up the sum of all the previous numbers, right?
Okay, that's right.
My throat is so
Perfect
hoarse.
for recursion. Okay, I'm gonna continue this lesson.
Okay, I'll stop streaming.
So, okay, we're still on compiling and executing. Sometimes when we compile, we want to give the output exit. Sorry, give me a second. Okay. Sometimes when we compile, we want to give the output executable file a specific name. Yeah, that makes sense. Otherwise, we're just always going to be doing a.out, which is kind of weird. To do so, the compile command is slightly different. We'll still need to write G++ in the file name in the terminal, but after that, there should be a -o, and then the name that you want to give to the executable file. So it looks the same, and then this is called a flag. We have a flag called O, and then we put the name of the new file that we want to do. So the compiler will then translate the C++ program hello.cpp and create a machine code file called hello. And then you can just execute hello. You don't even need like anything at the end. That's kind of cool. So to execute the new machine code file, all you need to do is type // and the machine code file name in the terminal. Whoa, okay. That's weird. So you don't actually need a file extension. But it defaults to a.out. Okay.
Yes.
Okay. So let's try and compile this.
Some coffee.
Hello.cpp, and then we add the flag -o, and we'll do hello. And it may look like it did nothing, but it did. And we do // hello, to run the hello executable file. And it worked. Nice. All right, comments. Wow, this is big stuff, guys. Programming is often highly collaborative. In addition, our own code can quickly become difficult to understand when we return to it, sometimes only a few hours later. For these reasons, it's often useful to leave notes in our code for ourselves or other developers. As we write a C++ program, we can write comments in the code that the compiler will ignore as our program runs. These comments exist just for our eyes. Comments can explain what the code is doing. It can leave instructions for developers using the code and add any other useful annotations. So there are two types of code comments in C++. There's a single line comment, which we already went over, which will comment out a single line, and it's denoted with 2 forward slashes preceding it. Just like this, 2 forward slashes, and then you can just type anything. You don't even need a semicolon to end the line. You can use a single line comment after a line of code. Oh, that's cool. Yep. This is true. It doesn't have to be the entire line. It can just be the rest of the line. So the double slash, all it does is it comments out everything after it, but not before it on that line. But there's also something called a multi-line comment. As you can imagine, if you wanted to write like a paragraph of information, it's kind of annoying to put a bunch of slashes in front of every single line. So with a multi-line comment, we will comment out multiple lines, and it's denoted with a slash asterisk to begin the comment and an asterisk slash to end the comment. This is pretty much universal in every programming language. Comments are pretty much the same. So yeah, let's practice adding a comment. Add a new line above include. And we're going to write a single line comment. Harry Potter. Nice. Compile and execute spell.cpp using the terminal. Okay. So g++ spell.cpp, and let's name it spell. And then we can do /spell to run the spell executable. There. And it runs the program just as normal without giving any regard to the comment. Easy peasy. Review. Congratulations. In this lesson you have learned compilation and execution using the terminal. Alright, we just learned about comments. Wow. I can feel myself becoming a career professional by the minute. Bjarne is gonna shiver in his boots when he meets me. Alright, compile and execute. So the process. So C++ is a compiled language. That means that to get a program to run, you must first translate it from human readable form to something that a machine can understand. That translation is done by a program called a compiler. What you read and write is called source code. So usually it's in an English-like language, such as C++. Pretty much all the programming languages you hear about are all compiled languages, because they're written in very English-looking words and stuff like that, and a computer just doesn't know anything about that. So the compiler translates all of that into something that it does understand, which is a bunch of ones and zeros, and then it can run the code. So typically, or actually I skipped one. And what the computer executes is called executable object code or machine code. It's a machine language. Typically, C++ source code files are given the suffix .cpp or .h. Interesting. So source code is in the preprocessor. I don't know what a okay, so we start with the source code, and then it goes to a preprocessor. I don't know what it does there, and then it goes to a compiler, and then it goes to a linker. I don't really know what that is either. And then it spits out something the machine can actually run. This is just another file. So yeah, we know what this is. This is a line that compiles our code and creates an executable file named hello. A compiler translates the C++ program into machine language code, which it stores on the disk as a file with the extension .o. Hello.o. A linker then links the object code with standard library routines that the program may use. I don't know what any of this means. A linker then links that object code with standard library routines that the program may use and creates an executable image, which is also saved on disk, usually as a file with the file name without any extension. Okay, so what's happening is you compile it, and it, at this stage, it has created object code. And what the linker does is it takes that object code and puts it somewhere on your hard drive that makes it readable so that you can actually execute the code. And it'll do that with the name that you selected, which is hello in this case, right? It'll create hello.o. Or it actually doesn't create hello.o. The compiler creates hello.o. And then you can, like, I don't know, it does some like weird magic, some voodoo, and then it creates an executable that is just known as hello. So you don't even need to type the .o. And then to execute it, you do this, right? So the executable is loaded from the disk to memory and the computer's CPU, or central processing unit. It executes the code one instruction at a time. So on the Mac, it's called the terminal. On Windows, it's called the command prompt. All right. Compiling XKCD. The number one programmer excuse for legitimately slacking off. My code's compiling. Hey, get back to work. Compiling. Oh, carry on. Okay. Nice.
Awesome. Let's go.
Ooh, it's quiz time. Which one is a single line comment in C++? This one. Hashtags are actually used for comments in certain programming languages. I think Ruby does that. I don't remember. It's been a while.
Good thing it specifies C++.
Yeah. True or false? C++ is a general purpose programming language based on the C programming language. True. What should go in the blank to output a string in the terminal? Oh, I thought I had to type. It's this std : cout.
Yes. But if you use namespace standard, you wouldn't even have to use the
Yeah, the std part just
:
leaves. I'm sure
Yeah.
we'll learn about that eventually, right? I hope.
Oh, wait, spoilers.
Yeah. Aha's trying to spoil the game for us.
The game, no.
In the diagram below, what are the two terminal lines used for? So you code, and then you save, and then this part is the compile and execution, right? This line compiles, this line executes. Where's that? Compiling and executing the program. There we go. What would the output be for a program like this? All we do is cout, which is the same as printing in most other programming languages. Hello, whatever this means. It's probably like, I don't know, maybe a name. It's gonna do hello. It's gonna be this with a new line at the end.
Yeah.
There. Oh, it's world in Mandarin. All right.
Nice.
Block letters. Sure thing.
Oh, no.
This is the
not
pro
block.
section of Codecademy. So write a C++ program called initials.cpp that displays the initials of your name in block letters as shown. Okay.
Oh, man.
Oh, we're just gonna manually code all that. All right. So my initials are S and L. Not mine. This person's. So their program would output SL like that. What are your initials? Take a look at the complete alphabet. Sure thing. All right, I'm gonna do a J and an H. Do a J. Okay, so these are 5 long and 7 tall. Interesting. So first, let's ride the code. Let's begin our stuff. I'm not gonna write a comment. Fun fact. It's so lame, Mom. Okay, we're gonna include the IO stream package that it needs in order to output onto the terminal. If you missed that, sucks for you. And then we have the main function, which is an integer function, and then at the end we're just gonna return 0, just, you know, just cause it did that once, and I feel like I'm obligated to now. So this is where our code is gonna go. What was that?
You're not really obligated to because it's assumed at the end.
I know, but I feel bad because they did it in like 2 of the exercises.
Oh.
All right, that. All right, so we're gonna need 2 lines. Well, okay, are we doing it all in the same line? Oh man, how many? So we're gonna need 7 lines.
Well, look at the alphabet.
STD : C out, and then we're gonna left shift. Okay, we're gonna put a new line, and then we're gonna just copy this 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, we got enough space for everything. Okay. I am going to bring this up to the side here. So the first line is gonna have to be a J. Luckily, that's 5 J's. 1, 2, 3, 4, 5. We're not even gonna put spaces. That's cool. And then we put a space between that and the next letter. And then the top of an H is gonna be an H with 3 spaces and then another H. H, 1, 2, 3, H. First line, done. Second line, space, space, J, space, space. That's the first letter. We put a space in between the 2 letters, space, and then for H, it's gonna look the same as the last one. So we're gonna have an H with 3 spaces in the middle and another H. And I can actually copy this and I can paste it in here for like 6 of these or 5 of these, and then I just need to edit one of them. So the fourth one, which is 1, 2, 3, 4, this one, the H's are actually going to be solid because it's the middle of the H that bars the 2 sides together. And then this, you know what, I'll stick it, oh, oopsies. I'll stick this in here too. But it's going to look a little different on the J and these 3. So we're going to put an extra J right here, and then we're gonna put it right here. Sorry if you're actually like trying to follow along. I'm just going fast. There's no reason to like care. All right, I think it's done. Save. Cool. Output your first initial. Oh well.
Oh, I want to try and figure this out.
What? It's done.
A and K. Wow, I want to do mine.
Oh.
God.
Oh, okay.
Nah, it's actually fine.
All right. I'm gonna compile it with G++. This is called initials.cpp, and we're just gonna call it initials. Oop, I could spell initials. Where's the O? There. Okay. Jeez. Initials.cpp -o initials. Great. Oh, what? Oh, I didn't spell initials right. See, the greatest bane of every programmer is being able to just spell basic words.
Yes.
Initials. There we go. Wait, did I still fuck up? In function. Oh, yeah. God, you need semicolons. Don't forget your semicolons. I'm not used to having to put semicolons at the end of every line because I was doing JavaScript for quite a long time, which does not require semicolons. Okay, save, and then I can run it. Huh? Oh, God, dude. You need a semicolon after every single line of code, which sucks. Do you need one after the function body? Haas, do you know?
Let me see.
I don't think you do, but I know
No,
that you do in
never.
like, I forget if Java you do. There's some programming languages where you do.
No, not in C++. You should be fine.
All right, I can
In,
finally run it.
In do while loops, yes, you do.
Oh,
need
that's
to-
right. All right, so as you can see, this time it ran, and also, it's important to note that we just worked through the process of debugging. This is called debugging, where we compile our code 5 times and nothing works, but it gives us little hints sometimes. Sometimes it's just useless and we have to figure it out on our own. But we were lucky enough that it recognized what the issue was, and it pretty much told us what we needed to fix. And we fixed it, and now it works. And you know it works if it compiles. It may not be what you want it to do, but it's at least compilable, so it's functional code, whether you want it to actually function the way it does or not. It at least functions now. So now we can execute it with /initials, because that's the flag that I gave it. Oh, God damn it, I can't spell initials, dude. Oh my god. Okay, I'm losing my mind. Alright. Wow. That looks beautiful.
Yay!
Yay. Alright.
Want me to do it as well? Alright, hold on. Let me not fuck it up like John. Oh, not like
What do you
John.
mean?
Let me unfuck the way I did it, because I did it in a really cringe way. Okay, and then end L. See how. Can you bring up the alphabet thing again, John?
Yeah.
Just waiting for on stream.
A.
A and K. Okay, so I need A. I think that works. Space. Spaces. 2 spaces, right? K. Oh. Shit. K. 1, 2, 3. No, 2, right? Yes. Okay. And L. Add a space to that thing. C out. A. 3. A. K. K. And L. C out. Still A. Oh, wait, that's like 5 A's in a row. I cannot put Endel in all caps. John, I can't see it anymore. John. So loud.
Oh my god, it's so freaking loud. I have to turn it off.
Yeah, watch this.
Can't hear you, Oz. I'm too busy red balling.
Oh my lord.
I used to
Okay.
play this all the time in school. Whoa. Oh, okay. That went way higher than I thought it would. Crazy.
1, 2, 3. A.
Checkpoint. Oh shoot.
Okay.
So bad. Oh man. I thought I could jump higher. No! Get back here! Yes! I mean...
And L. C out. Oh, this is gonna take a long time. I think I said that. Yeah. My last line.
No, let me out. No.
It's scuffed, but it works.
I made it. Checkpoint.
Alright, time to send it.
Okay. I did it. Alright, you done?
Yes.
Okay. Want to share with the class?
Sure.
Okay.
Screen Eclipse. Go live. There it is.
Hey, it looks much better spaced on Eclipse. Actually, the K looks like it's almost uneven, but maybe that's just because of the angle I'm looking at my screen.
A little bit. This is definitely uneven right here.
Yeah, what the heck? What happened there?
I don't know. It's
You need
Yeah,
to put a space. Get rid of one of the spaces in the middle, and then put a space on the right of that A below. Yeah, get rid of one space and then put another space on the right of the A. There.
got it.
There you go.
There we go. I haven't noticed that. Thank you, John.
Yo, Pog. Nice. Okay.
Nice.
We will come back to you, Red Ball, I know. Alright, we're done with this project. That's what Codecademy Pro gets you in life.
Alright, that's enough coding for me. I'll see you
Really?
later, John.
Aw,
Yeah.
so
This
sad.
is snail's pace.
What do you mean? You're the one that we were waiting for 5 minutes.
Dude, I was
I got
just
through
trying to
half a Red Ball.
understand- No! Okay, whatever. I'm not gonna be bullied on live stream. Goodbye.
Goodbye.
Please.
Hey, I mean, we already did finish the Hello World thing. This whole thing, I'm gonna upload it or update it. Nice! We're 11% of the way through. Give yourself a hand. Oh, wow. 25 hours at this rate, it'll take me 100 hours. Having guests on and shit. What is this? It's crazy. I do have variables though, so I don't know. I feel like if I start a section, I want to finish it before I like stop doing this on stream, and I'm gravitating toward playing Red Ball right now, so I'm gonna take a Red Ball break, just like in real life, you know. In real life, when you're coding, you pretty much always take a Red Ball break if you're like a professional. Oh no, that wasn't enough. Oh, I have to restart. Oh shoot. Okay. There we go. If you would like me to continue coding, I can, by the way, but I figure that you don't care. It's up to you. I don't mind either way. No! Oh, alright. I can do this. I can do this. Dude. These ramps are kind of difficult. You gotta jump at the end. Gotta get the momentum just right. Oh, shoot. How did I do that so easily the first time? What the heck? I couldn't jump. Why couldn't I jump? We would try and speedrun Red Ball. And by we, I really just mean like, I don't know, Jack and Liam. Oh, Parker's back. You took a shower and come back to this? How did you take a shower that quick? Yo, what's up, Parker? Yeah, I know. Red Ball? Perfect. We would speedrun this, and clearly I did not speedrun because I was not as professional as Jack or Liam. What happened to C++? So, we can still do that if you would like. It's sort of up to you. So we finished the Hello World module or whatever. We finished this. Oh, okay. Oh. There, we finished all this, and I didn't want to continue unless, like, you wanted me to finish the variables as well. It's up to you. There's 3 projects in this, and there's only 1 lesson. Okay. Do whatever makes you happy. Oh, I see. You see, I was playing Red Ball while Ahaz was finishing up his code. So that's why I'm on Red Ball right now. You know what? I don't actually want to close it because I'll lose my progress, but we will begin variables. I know. Wonderful. So these are all of the different types of variables, or I should say primitive variables. That's really not important right now. The Hello World program simply writes to the screen. It does not need anything. It doesn't read anything. It doesn't calculate anything or allow for us to input anything. So that's no fun. Real programs tend to produce results based on some input that the user of the program gives, rather than just outputting the same thing every time. To read something from the keyboard, we first need somewhere in the computer's memory to store data. That is where variables come in. A variable is simply a name that represents a particular piece of your computer's memory that has been set aside for you to store, retrieve, and use data. So basically, we never did this in my class. Did you really not do this in your class? Like, how is that possible? Maybe you were just too busy playing Red Ball, you know? Like, what happened? I'm confused. Like, Parker, I feel like maybe you would have actually, like, benefited from watching the first Hello World part, in case there was any confusion about the compiling and executing of the code. That's so weird. So weird. Man, what the hell? God. Simply put, a variable is a name that is assigned to data, and that data is stored in the computer's memory. That's all you need to know. You can use variables to use that data. And there's 5 different types of primitive data types. There's an int, which is an integer number. There's a double, which is a floating point number, or aka a decimal number. There's a character, which is just an individual character. A string, which is a sequence of characters, or a word, or something like that, or a sentence. And then there's booleans, which are only true or false. Every variable has a type, which represents the kind of information you can store inside of it, which is this. These are types. It tells your compiler how much memory to set aside for the variable, and it defines what you can do with the variable. So yeah, like a double, it actually takes up more space in memory than an integer, because there's an extra set of oh no, there's more bits in the computer to represent the decimal part of the. A double is just a decimal. It's a floating point. You've never used a double? Holy crap. It's called different things in different. Yeah, it is a float. Well, it is a float. Maybe do you know if maybe floats are oh, okay, interesting. It's possible. That's very possible. Yeah, that's very, very possible. Yeah, it'll usually be called a double or a float. So yeah, they're the same thing. I think a double might be more than a float. It might have more bits. So yeah, I don't know. But in fact, I could just look that up. Float C++. So float is 4 bytes, and a double is 8 bytes. And then a long double is 8 bytes. Huh. There are 3 different types of floating point data types. There's floats, doubles, and long doubles. As with integers, C++ does not define the actual size of these types, but it does guarantee minimum sizes. On modern architectures, floating point representation almost always follows IEEE. This is a... damn it. I actually know what this stands for. Oops, IEEE, there. Institute of Electrical and Electronics Engineers. It's just a standard for binary in this case. So in this format, a float is 4 bytes, a double is 8, and a long double can be equivalent to a double 8 bytes, which is okay. Or 80 bits, often padded to 12 bytes or 16 bytes. Okay. And a byte is 4 bits, right? So a float is 16 bits, a double is 32 bits. And then if you need more than that, you go for a long double. Oh, and they can hold positive and negative values. Important. This is important. Okay. Great. I guess we know the difference now. So yeah, that's it. Next, declare a variable. Every variable in C++ must be declared before it can be used. There's actually something called retroactive declaration. I don't actually remember if that's what it's called, but yeah, variable time. This is super advanced stuff. I wouldn't be surprised if you have no idea what this is. Sometimes, okay, suppose we're going to be garbage language. Just be glad you never did C. Did you have to do C and then C++? Is that how that worked? That kind of sucks. C's not even object oriented. Like, it took us a week just to learn how to do a simple variable. Yikes. Yikes, man. Yikes. That sounds terrible. Yeah. I'm not surprised. This, after all, is supposed to be an improvement on C, and C++ is still known for being way overcomplicated sometimes, so. Suppose we are building a game and we want to keep track of a player's score that goes from 0 to 10. We need a variable. Before we can use a variable, we must declare or create it. To declare a variable, we need to provide 2 things. We need to provide the type and the name. So to declare an integer variable called score, we need to write int score. The int is the type of the variable, and the score is the name of the variable. Also, the semicolon is how we end a statement. In C++, variable names consist only of upper/lowercase letters, digits and or underscores. All right, so you can have digits, underscores, and any letter. That doesn't leave a whole lot, but, you know, no special characters like ampersands and stuff like that. C++ is strongly known as, C++ is known as a strongly typed language. So if you try to give an integer value a decimal number, you're going to get an unexpected result, warnings or errors. Inside the variable, so a strongly typed language is just one that makes you declare the variable type, and you can only use that variable type every time you Yeah, you can't assign it anything that's outside of that. So inside the variable.cpp file, declare an int variable named year. Oh, all right, int year. Nope, there, semicolon. All right, run. Type the following commands in the terminal and press enter. Why? It won't do anything. G++, we're gonna do variable.cpp. Guess we're not gonna add a flag, and then we'll execute with ./a.out. All right, that's kind of weird. So initialize a variable. So after we declare a variable, we can give it a value. You don't have to, but you can. Suppose that we have declared an integer variable called score. To set it to 0, we can simply write score equals 0. The score is the name of the variable. The equal indicates assignment, and 0 is the value you want to store. So in C++, a single equal sign does not really mean equal. It means assign. In the code above, we are assigning the score variable a value of 0. So you've declared an int variable year. Let's give the variable a value of 2019. So yeah, this is the difference between declaring and initializing a variable, which honestly doesn't make a huge difference most of the time. But initializing a variable is just when you give it a number, or when you give it a value, like 0. That's literally it, which is kind of silly, but it's important to make the distinguish, I guess. Oh, we need 2019. Oops, 2019. Type the following commands in the terminal. Okay, so we're gonna compile and execute G++ variable.cpp. I'm gonna set a flag for -o, and then I'm gonna set variable, so I can just type that next time. And then I'm gonna do /variable. Hello. Wow. Okay, so it's actually going to make me use this exact code. All right. Fine. It's not smart enough to know. God, why can't I type today? And then we just do /a. Oh. Fine. All right. So we can combine these steps into a singular line, as I'm sure you are aware if you have done this before. We can both declare and assign a variable to a value to a variable in a single initialization statement. Suppose we have these two lines, so we're declaring and then we're initializing. We can actually combine these two lines into a single line of code. We can declare and then initialize. So this means that we are declaring an integer called score and setting it equal to 0, like this. This is the declaration, and then this is the initialization right here. So we only need to declare a variable one time. It is highly suggested to initialize a variable before using it later. In your program, declare and initialize an int variable named year and initialize its value to 2019. Declare and initialize, wow, int year equals 2019 semicolon, great, all right. Such a clean website. Oh yeah, Python, dude, I love Codecademy, I really do. Codecademy is super awesome. It's just so, they do a really good job at just like boiling it down to like really simple things. They don't clutter you with like a bunch of garbage. They just show you what you need to work on, and that's it. And they give like pretty clear and concise constructions, and it's just a clean interface. I really do like it. All right. Arithmetic operators. Ooh. So computers are incredible at doing calculations. Now that we have declared variables, let's use them with arithmetic operators to calculate things. Here's some arithmetic operators. So plus for addition, minus for subtraction, asterisk for multiplication, slash for division, and percentage for a modulo, which divides and then gives the remainder. Yeah, I'm using Pro. Yeah. So in Pro, you get all of the projects that go after the lessons. which can help you like set in stone your new skills. This isn't actually my account. This is my old boss's account, my friend's account. And he got it for me so that I could learn how to do Ruby stuff. And I did a bunch of courses for Ruby and stuff like that on Codecademy. But now I get to use it all the time. So, pretty awesome. Yeah, alright, so the order of operations can be specified using parentheses. Nice. Is Ruby easy? I mean, I can't tell you if it's worth it for you. I just can't. Like, that's something that you have to figure out. Like, it's different for everyone. What I can say is that if you are having trouble learning the fundamentals of programming and you really want to know, I think that that Pro is probably the way to go. Or, you know what? Okay, let me be a little more specific. If you think you're going to need to program using this language outside of just like classes, so like for Parker, you're a CS major. Eventually, you're gonna want to be able to like solidify these skills and take it to your next class or to the real life at some point, right? So I think for Parker, it probably makes a lot of sense to get Pro. You can get it 35% off for a student discount, so that helps. But I would only do it if you are having trouble understanding what your teacher's talking about, because some teachers just suck, and some teachers' teaching methods just don't work for every student. So if you think that like your teacher isn't giving you enough info, you could try doing yeah, exactly, right? I use Free Code Camp every once in a while too, or I've like watched a few other videos. There's also like there's a lot of good YouTube videos too. Like, you don't need Codecademy. Codecademy really makes it simple. It just puts everything in one place. Where like on YouTube, yeah, exactly, perfect. I've done similar things. If you watch videos, it really, the benefit of even using Codecademy in the first place is just having the learning material next to the coding, the place where you're actually going to code. So you get like hands-on experience while you're learning. Whereas in a YouTube video, you'd have to switch between the video and then like an IDE or something. So yeah. If you're just learning how to code as a hobby, I wouldn't bother with the Codecademy stuff. Honestly, I wouldn't bother with the Pro stuff. I love Codecademy free still. I still think it's great. Ultimately, you don't get like enormous perks for getting Pro, unless it's like a course that's not even available for non-Pro users, but that tends to be more specialized stuff, like the authentication one that I went through and all that. So I don't know, it depends on your personal needs for it and stuff like that, and your other options and features. But yeah, so anyway, we can basically choose our order of operations by using parentheses. We've probably all done this in a calculator before. So yeah. Moving on. In math.cpp, we have already declared and initialized a variable called score for you. Very in-depth response. Yes, I know. It's my job, Parker. This is what I'm here for. We have already declared and initialized a variable called score for you, set to 0. So let's change its value by giving it the value of 1234 multiplied by 99. All right, score is equal to 1234 times 99. Oh wait, I always forget the semicolon. Still not used to having to put that again. Thank you, oh wise one. Right. All right, and then we're gonna output that score. std cout left shift score left shift new line. All right, so this is how we can check what the value is. We just have it print to the terminal. Notice how when we want to output a variable, we don't add double quotes around its name. Yeah, so we have 2 left shifts here. I'd like to get more in depth about why you have to put a left shift operator here. It's probably very technical, so I'll probably just do that off stream. But like, it fascinates me that you have to do a left shift operator, which I went over earlier, but I don't think anyone was actually watching, or anyone that's here anyway. If you want me to go over what a left shift operator is, or a right shift, it's very simple. I'll show you, but otherwise I'm gonna continue. So yeah, we output. I guess we can just run, and then we compile and all that. So g++ math.cpp, and I'm gonna set a flag for math. I always forget the semicolon. When you do C++ as an IDE, you need to define your namespace, because if you do cout and cin on its own, it won't work. Yeah, I know, but you only need to do that if you don't have std : right? Also, you need the IOStream package, because that lets you print to the console, and it also lets you retrieve information. But yeah, I don't think it's gotten to that yet, Parker. I don't know if it's ever going to get to that, if I'm going to be completely honest. I don't know if they ever like help you define your own namespace so that you don't have to put this part. But I'd like to go over that, because if I'm actually going to be using C++ seriously, I need to know how to do that. But yeah. Okay, I actually have to compile now. g++ math.cpp -o math. Great, and /math. Alright, this is what 1, 2, 3, 4 times 99 is. Chaining! Interesting. Alright. Now that we have outputted a variable, and we have also outputted things using multiple couts, let's take a closer look at cout again. Oh, it's interesting. If we have the code below, where we create a variable called age and set it to 28, and then we print hello, I am, and then the age, and then years old, a new line. It will output hello, I am 28 years old. Notice how we use quotes around the characters in hello, I am, but not in age. Yeah, because age is a variable. So we don't use quotes when we want a literal string. We don't use quotes when we refer to the value of something with a name, like a variable. So now, is it possible to write the cout statements within a single line? Of course. You can write multiple left shift operators to chain the things you want to output. Great. For the same code above, you can also do that. What are we gonna do? Oh, player score : okay, std or std : cout, double left shift, and we'll put player score, and then score, and I think I'll put a new line as well. I don't know if it asks you to. Okay, whatever. Compile g++. It's game.ccp this time. Game. Oops. Uh-oh. I need to put the O. There. And then /game. Player score 0. Oh, I should put a space here. Whatever. Next. Hello, I am 28 years old. I'm sure you are, Sam. Sure you are. User input. So like we're gonna get into cin. Like we mentioned in the introduction, another way to assign a value to a variable is through user input. A lot of times, we want the user of the program to enter information for the program. We have cout for output, and there's something called cin that's used for input. Here it is. and it's a right shift operator. Interesting. So the left, or the name cin refers to the standard input stream. Pronounced cin for character input. The second operand of the right shift operator, aka this part, get from, specifies where that input goes. Yeah, okay. Yeah. So, whatever. Add the following code, stdcin tip. Okay, std cin tip. Oh, alright. Right. Okay, so std, I guess we're just gonna tell them how much they tipped. Okay. And then we compile and execute. It's called tip.cpp. And a flag called tip. /tip. Enter tip amount. $30. You paid $30. Great. Oh, I could do a new line. Alright, next. We only have 2 more. All right. Challenge, temperature, part 1. Ready to be challenged. Now that we've learned about the basics of variables in cin, let's write a program. The mad scientist Kelvin has mastered predicting the weather in his mountainside meteorology lab. Recently, Kelvin began publishing his weather forecasts on his website. However, there's a problem. All of his forecasts describe the temperature in Fahrenheit degrees. Let's convert a temperature from Fahrenheit F to Celsius C. The formula is the following. Nice. First, Google the current temperature of New York in Fahrenheit. In New York. 33 degrees Fahrenheit. Okay. So we're gonna create 2 variables that are doubles, and we're gonna do temp F and temp C. Calculate the temperature, right? Temp C equals temp F. What is the, oh, okay. Minus 32. Divided by 1.8. Cool. Stored in temp C. Shoot, gotta put a semicolon at the end. Alright, display the result. Great. std cout. God, I actually can't type. I don't know why. All right. What is the what's the formula? Temp F minus 32 divided by 1.8. what temp is that, I mean, yeah, that's the right number. What's wrong here? I don't understand. Isn't it liking this? Is it because this isn't... I mean, it doesn't even say that there's an error with my code. It's just not accepting it. Does it require that I do one of these two? Because I did temp, not temperature. I'm gonna try that. I'm gonna see if maybe they're just being really annoying with this. Yeah, that's it? Really? Come on, people. Update your program. Make it a little smarter than that. Alright, let's go back to the temperature CPP that we wrote. This time, instead of giving temp F a value of the current temperature in New York, let's ask the user what the temperature is using cin. Alright, so ask the user. We're going to do std cin. Oh my gosh. Cin, and then we're going to assign that to temp F. Alright, and then the rest is there. Going to compile it, so g++ temperature dot cpp dash o temperature dot slash temperature, and then, oh, I didn't actually like prompt the user like it said to. It still accepted that. That's kind of weird. Whatever, might as well, right? 2. Okay. Yep, it knows. Alright. You made it to the end of the lesson. So we learned what variables are. We learned all the types of variables, that equal signs means assignment, and we learned that cin is to receive input. The BMI is commonly used by health and nutrition professionals to estimate human body fat in populations. It is computed by taking the individual's weight in kilograms and dividing it by the square of their height in meters. Complete the BMI.cpp program. Okay, why not? Double height, weight, BMI. What? Type in your height. Meters. Oh. Type in your weight. Kilograms. Wait, there. Alright. BMI equals weight divided by height. What is, how do you square in this programming language? C++, exponent. Oh, you need to use a package for it? That's kind of lame. I won't bother. Alright. And then it'll C or std cout your BMI is BMI right, and let's try and compile it here. BMI.cpp dash o BMI. Oh, uh-oh. Did I forget something? Expected. Of course I did. It's a freaking semicolon as usual. So I need to run to save it. John, BMI exposed? Yeah, true. This is gonna be so embarrassing, guys. Alright, /BMI. Oop, I misspelled. I misspelled a 3-letter word. Type in your height in meters. I don't know what meters. Okay. 6 foot 200 meters. Oh no, you can't paste? Bruh. Sometimes consoles suck. Okay, 1.88. In kilograms, I actually don't know exactly how much I weigh anymore. I think it's probably around 185. Let's see. 84. My BMI is 23.7664. Man. Alright. Oh, we got the quiz. Hey, poses. What would the output be for this piece of code? So we're initializing player level, and player level is 7, and then player level 7. There we go. Alrighty. Okay. Bool x equals false. What type or what data type is x? Probably a bool. Interesting. What are variables used for in C++? Storing data, for the program to be used across multiple platforms, and for documenting code. Nice. Division 3. What does cin do? Cin character input, used to read input. There. In this declaration initialization, what is the variable name here? What is the correct way to declare an integer named age? Int age. Very healthy. Is that very healthy? I don't know. What is the correct way to declare an integer named age? Didn't I already do this? Oh, I didn't click continue. All right. Up next. Ooh, a project. Yeah, so like sometimes in Codecademy Pro, you'll have a lot of extra projects that like free users don't have. So like a lot of tabs open. So yeah, here you can see that there's a lot. There's 3. Actually, there's 4, but I think one of them is possibly not Pro. I don't know. Anyway, let's see. What is this? Dog ears. Sam, you'll be big and strong one day. I know it. Dogs mature at a faster rate than human beings. If you own a dog, you might have heard this one rule. A year for Snoopy equals 7 years for you. Turns out the math isn't that simple. Dogs mature more quickly than we do early on. Here's how we can convert your dog's age into human years. The first 2 years of a dog's life count as 21 human years. Each following year counts as 4 human years. So a 1-year-old dog is 10.5 years old in human years. And a 2-year-old dog is 21 years old in human years. This is about to get more complicated. Before you start doing the math in your head, let a computer take care of it. Write a C++ program called dog_years.cpp. What? In human years, any dog older than 2. If you get stuck during this project, or would like to see an experienced developer work through it, whatever. Can I just do this on my own? Do I have to? I might as well follow their steps. Why not? So int dog age. I think Sherlock is probably a 14 or so now. Maybe. We're not really sure anyway. So, this version of the program is for dogs older than 2 years. Great. Okay. Oh, we need a comment, huh? Bruh. Let's declare 3 more int variables. All right, so we've got early years, later years, and human years. Oh man. There we go. Variables used for processing. All right. Okay. Early years, a value of 21. Oh, okay. Each following year counts as 4 human years. So the equation looks something like later years equals dog age minus 2 times 4. True? Well, I guess I should just... Or sorry, no. Later years equals minus 2 times 4 early years. Or sorry, not early years, dog age. That's kind of old. Dog age minus 2 times 4. Okay. Add early years and then later years together and store that in a variable called human years. Human years. And then we're just going to add early years and later years. Also, I always forget the semicolons. There we go. Yeah, Sherlock is ancient. And then we're going to tell... My name is what? We didn't ask for a name. Alright, statement that displays your dog's name and age in human years. You can fill in the blank with your dog's name and age with the value of human years. Alright. So we'll put, okay. My name is Sherlock. Ruff. I am human years. Years old in human years. You can fill in the blank with your dog's name. Yeah, okay, I did that. Save. And now we compile g++, dog years.cpp -o. You know what? I'm not even gonna bother. And then we do ./a.out. My name is Sherlock. Ruff. I am 16. Oh, what a Chad. I am 69 years old in human years. Oh, of course he is. That's a good boy. I'm such a child. Great work. Try changing dog age to see what happens. You have a dog, right? How old is your dog? Four? How wonderful. Alright. I won't bother changing. GG. Save, and we'll run that one more time. Or, oops. We gotta compile it with this big line of garbo. Not god year, dog years. Dog years. No input file. Oh shoot, I didn't type .cpp. Yeah, how many god years is that? ./a.out. 29. Your dog is 29 years old. Older than you. Quadratic formula. Okay, fine. Corresponding blah 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 solves the quadratic equation for the x's. No, right? If you get stuck during this project, so we're gonna have to import a math package, right? Where's that? Yeah, we do. Okay, this is the first time we're gonna be importing a new package. Oh wait, it's already there. Okay, well, guess we won't. Okay. Int A, int B, int C. All right. Oh, then we want decimals. Okay, then double. You know what? I'll do float. We don't need a lot of decimal places. Float. The output. Okay. std cout. Did one colon. Enter A. Want B here. We're gonna want C. Oh, C here. Right, and then here we're gonna use C in to see what they say, and we're gonna do it to A, and then don't forget the colon, semicolon. Bro, I can't spell. I don't know why today. I'm having such a hard time typing. Okay. Okay. We're also gonna get two roots. Float root 1. Root 2. Can you declare variables on the same line in C++? On the same line, C++. Okay. Okay, yeah, you can. Nice. Root 1, root 2. A, B, C, all that. Nice. All right. There are two roots. For root 1, the equation has a positive sign, and for root 2, it'll have a negative. Use C++ math operators to solve for root 1. Okay. This is where math under here. Okay, root 1 is equal to B, okay. It's -1 plus we do std that the square root. Okay, so you can use std : square root to get a number's square root. So std square root is a built-in C++ function you gain access to by including the cmath library, which is up here at the top of the file. For example, std : square root 9 would be 3. We'll explain that all later. You better. All right. I could also do power, I believe, but I'll just keep it to b times b because I'm lazy like that. 4 times a times c. Cool. And then we wrap all of this around in parentheses. It's getting kind of long and gross. And then we divide by 2 times a. Cool. And then for the next one, it's a minus sign. So root 2 is equal to all of this. Copy, paste, but this is a minus. Great. Let's put these values using, yeah, okay. So, std, cout, root 1 is root 1. And we can copy that and paste it over, but with root 2. Great. All right. All right, save. I'll compile that with G++, quadratic.cpp. Okay. Let's see. Cin. What are the errors here? Cin was not declared in this scope. Oh, dang it. I did 1 colon for this, and then I copied it. Oopsie daisy. Also, there should be semicolons at the end of these formulas. All right, save. Try that one more time. It worked. /a.out. Enter A. So we're gonna try these. So A would be 6, and then -7, and -3. Root 1 is 1.5 and negative. Hey, it worked. Nice. Very, very nice. Alright, we're done. Oh, I didn't. There we go. This is gonna be the last project, and then I think I'm gonna be done for the day. You just returned from a trip to South America. The countries you visited were Colombia, Brasilia, and Peru. You arrived back in your country with some foreign currencies from these countries. Write a C++ program called currency.cpp that prompts the user for the amount of each foreign currency. Your prompts should look like: your program should then convert the amount entered by the user and display the total amount of USD. Your final output should look like this. If you get stuck during this project or would like to see an experienced developer work through it, I don't care. Alright, great. So we're are we gonna do decimals? I don't know. Are we doing decimals? What are the test cases? Sample solutions? Wait, is this just the solution to the code? Oh, it is. But they use doubles. Good to know. Alright. So we'll do pesos, reais. I don't actually know how to say that. Or in souls. I don't know. I don't know. Is that souls like Dark Souls? Be kind of spooky. That was the currency. We'll do float. Pesos. Reais and souls. You'll need another variable to store the amount you have in dollars. And I'll put dollars. Compile and execute the code to make sure it's bug-free before moving on. Whatever. You'll want to ask the user the first question. std cout. Enter number of Colombian pesos. Alright, and semicolon, and then we do cin pesos. Ooh, gotta do std colon. Alright. Great. And then we're gonna do that with the other currencies, I assume. Yep, okay. Dang it, I keep hitting the wrong keys. I'm having fat finger syndrome, fortunately. I don't know where these are from. What did it say? Brazilian. Okay, so this one's Brazilian. And this one is Peruvian. Okay. Great. Okay, Google the conversion rates. Ah, can it tell me? Great. All right. We'll go with the old numbers. Okay. Write an equation that solves for the total USD. Okay. I'm just gonna set variables, just cause, you know. Float econv equals 0.00032. This is R and this is S. This is 0.7. This is just point. All right. Okay. All right. We got pesos times pconv plus raise times rconv plus sols times sconv. Great. Display the total amount of USD. Save. And let's compile that. See if it works. Oh, oops. And of course I forgot a semicolon somewhere. Here it is. We'll never not do that. Okay. We do ./a.out. Let's just say we've got 151, 23, or it's $22. That's nothing. Okay. All right. Last thing right here. It's the article on data types. C++ provides a rather large number of types. However, you can write perfectly good programs using only 5 of those: integer, double, character, string, and boolean. Here are some examples of declaring and initializing variables. Great. Data type modifiers. So, as the name implies, data type modifiers are used with built-in data types to modify the length of data that a particular data type can hold. Data type modifiers in C++ are signed, unsigned, short, and long. We will learn about these in a bit. Can't wait. Constant. There's a thing called constant. It's a signifier for variables that can't be changed during your program execution. Simply add the keyword constant before the data type using declaration to make the variable not modifiable. And then there's type conversion. A typecast is basically a conversion from one type to another. The notation is you put the type that you want it to become in parentheses in front of the variable name, and then it just means convert the variable name to the type that you want. Just like right there. So going from a double to an int simply removes the decimal. There's no rounding involved. All right. We're a quarter of the way through already. Wow. We're like a quarter of a professional. That's crazy. I'm sure there's nothing to be learned outside of this course, by the way. Absolutely nothing. Next up is going to be conditional statements, and then loops. That should be fun. But for now, that's going to be the end of it for me. And that's probably also going to be the end of the stream, because I don't really know what else to be doing. All right. Okay, that's gonna be it. That was fun. I hadn't streamed in quite a while. A couple weeks at least. I don't know when I'll be. We're gonna watch SpongeBob now? Alright.
My back here. The hell?
Oh, yo, what? How'd you get here? What?
I don't know. I was going to message you, and it just bothered me. While I'm here, I guess I'm just gonna ask. Do you want to watch SpongeBob like soon?
Yeah,
Ish.
yeah. What?
All right.
Did you talk to Weeb at all, or did you guys just independently say this?
I was going to talk to. Well,
You
Yeah, I talked
haven't
to
yet,
Weeb,
or
like-
you have?
I have.
You
I
have. Okay.
No, I was playing a game,
All right.
and right before I started, yeah.
What the hell?
Yes. We're not debating you. All right.
So weird.
All
All right.
Bye, John.
Adios. I'll be ready in a moment. Thanks for coordinating that, Weeb. The call. All right. That's gonna be on the stream. I'm gonna watch SpongeBob. Adios. Bye bye.